Welcome. 8th Standard Science Part 2, Chapter 13, Light. As per 2025-2026 Karnataka State Board Syllabus, question answer. Exercises. Question number 1. Suppose you are in a dark room. Can you see the objects in the room? No. Can you see the objects outside the room? Yes. Explain. If you are in a dark room, there is no light inside. Vision works because light reflects off objects and enters your eyes. Objects inside the room, since there is no light inside, objects in the room cannot reflect light to your eyes. Therefore, you cannot see the objects inside the room. Objects outside the room. Even if there is light outside, the room is dark and enclosed. So, light from outside cannot reach your eyes inside the room. Therefore, you can also cannot see objects outside the room. Conclusion. In complete darkness, you cannot see anything, inside or outside. Seeing requires light to reach your eyes. The ray of light from the reflection should fall on your retina. Then only you can see. Second question. Differentiate between regular and diffused reflection. Does diffused reflection mean the failure of the laws of reflection? Regular reflection versus diffused reflection. Feature regular reflection, diffused reflection. Surface. For regular reflection, surface should be smooth, like a mirror or a calm water. Diffused reflection, rough, like paper, wall, unpolished wood. Nature of reflected rays. Reflected rays are parallel in regular reflection. Reflected rays are scattered in all directions. Diffused reflection. Image formation forms a clear image. No clear image is formed. Example, mirror, calm water surface, white paper, cloth, walls. Second question, does diffused reflection mean failure or loss of reflection? No, it does not mean reflection has failed or is lost. Reflection still occurs. The law of reflection, angle of incidence is equal to angle of reflection, is still valid at each tiny point on the rough surface. The difference is that the reflected rays scatter in many directions, so our eyes cannot see a clear image. Key idea, diffused reflection is normal for most everyday objects. It just prevents the formation of sharp images. Question number 3. Mention against each of the following whether regular or diffused reflection will take place when a beam of light strikes. Justify your answer in each case. A. Polished wooden table. Surface. Type of reflection. Justification. A. Polished wooden table. Type of reflection it forms is regular reflection. Surface is smooth and even, so the reflected rays are parallel and give a clear reflection. B. Chalk powder. Diffused reflection. Chalk powder has a rough and uneven surface that scatters light in many directions. C. Cardboard surface. Diffused reflection. The surface of cardboard is not smooth, so light is reflected regularly. D. Marble floor with water spread over it. Regular reflection. The layer of water makes the marble surface smooth, allowing light to reflect regularly. E. Mirror. Regular reflection. The mirror has highly polished and smooth surface that reflects light regularly and produces clear images. F. Piece of paper. Diffused reflection. Though paper looks smooth, its surface has tiny irregularities that scatter light in different directions. Question number 4. State the laws of reflection. The laws of reflection describe how light behaves when it strikes the surface. There are two main laws. First one is first law of reflection. The incident ray, the reflected ray, and the normal. The imaginary line perpendicular to the surface at the point of incidence all lie in the same plane. Second law of reflection, the angle of incidence. Angle between the incident ray and the normal is equal to the angle of reflection. Angle between the reflected ray and the normal. Angle of incidence equal to angle of reflection. Key points to remember. These laws apply to all types of reflection, whether regular or diffused. Surface can be smooth or rough, but the law still holds locally at each point of incidence. Question number 5. Describe an activity to show that the incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. Here's the simple activity you can do to show that incident ray, reflected ray, and normal lie in the same plane. Materials needed: plane mirror, white sheet of paper, pencil, protractor, optional, pin or marker. Procedure. First one, place the mirror vertically on the table. Tape it to keep it stable. Second, place a white sheet of paper in front of the mirror. 3. Draw a line along the base of the mirror on the paper. 4. Mark point on the paper near the mirror as the point of incidence where the light will strike. Fifth, place two pins on the paper such that the line joining them would represent the incident ray coming to the mirror. 6. Look at the images of the two pins in the mirror. Place two more pins so that a line joining them passes through the image. This line represents the reflected ray. 7th, draw a normal at the point of incidence, a line perpendicular to the mirror surface. Observation. You will see that the incident ray, reflected ray, and normal all lie in the same plane, the plane of paper. If you tilt the paper, all three lines remain in that plane. Conclusion. This activity visually demonstrates the first law of reflection, showing that incident ray, reflected ray, and normal lie in the same plane. 6th, fill in the blanks in the following. A. Person 1 meter in front of the plane mirror seems to be 2 meters away from his image. Explanation. The image in the plane mirror appears behind the mirror at the same distance as the object. So the distance between the person and the image, 1 meter plus 2 mirror and 1 meter to the image, that is 2 meter. B. If you touch your right ear with right hand in front of the plane mirror, it will be seen in the mirror that your right ear is touched with the left hand. Explanation. The plane mirror produces laterally inverted image, so left, right positions appear swapped. C. The size of the pupil becomes larger when you see dim light. Explanation. In dim light, pupil dilate to allow more light to enter the eye. D. Night birds have more rods than cones in their eyes. Explanation. Rods are responsible for vision in the dim light, whole cones are for color vision. Night birds need better night vision. Choose the correct option in 7-8. 7. The angle of incidence is equal to angle of reflection. A. Always. B. Sometimes. C. Under special conditions. D. Never. Answer is always. According to the second law of reflection, the angle of incidence is always equal to angle of reflection. This holds true for all reflecting surfaces, whether smooth or rough, locally at each point on a rough surface. Eighth question. Image formed by a plane mirror is A. Virtual behind the mirror and enlarged. B. Virtual behind the mirror and of same size as the object. C. Real at the surface of the mirror and enlarged. D. Real behind the mirror and of the same size as the object. Correct answer is B. Virtual behind the mirror and of the same size as the object. Explanation. A plane mirror always forms an image that is virtual, cannot be projected on a screen behind the mirror at the same distance as object in the front of the same size as the object. Plane mirror do not enlarge or reduce the size of the image. Question number 9. Describe the construction of kaleidoscope. Here, clear description of construction of kaleidoscope. Material needed 3 long rectangular mirrors of equal size. Cardboard tube like the thick paper roll. Colored beads, small pieces of glass, and bright colored paper. Transparent sheet or glass piece. Opaque cover for one end of the tube. Step 4 construction. Arrange the mirrors. Place 3 mirrors inside the tube in the shape of an equilateral triangle forming prism. 2. The reflecting surfaces of the mirrors should face inside the triangle. To fix the mirrors in the tube. Secure the mirrors so that they stay in position. This forms the mirror chamber of kaleidoscope. 3. Prepare the viewing end. Leave one end of the tube open for looking through. 4th, prepare the object chamber. At the other end, place the transparent sheet or glass. 2. Put colored heads or small piece of colored glass paper between 2 transparent slits. This forms the object chamber. Cover the end to prevent the objects from falling out, but make it rotatable if you want changing patterns. Working. When you look through the open end and rotate the tube, light enters, hits the color objects, and reflects multiple times between the mirrors. The multiple reflection create the symmetrical and beautiful patterns which are constantly changing as the tube is rotated. Question number 10. Draw the label sketch of the human eye. This is the human eye. Retina, optic nerve, cornea, lens, iris, ciliary muscle. 11th. Wanted to perform activity 13.8 using a laser torch. Her teacher advised her not to do so. Can you explain the basis of the teacher's advice? He is beaming the laser torch on the other people's eye, on and off, on and off. Teacher is telling him to avoid this. Why? The reason is the teacher advised Gurmeet not to use laser torch for activity 13.8 because laser light is very intense and concentrated. Looking directly into the laser beam can damage the retina, potentially causing permanent eye injury. Even though the activity is about observing the pupil's response to light, a normal torch or LED light is safe, whereas a laser is dangerously bright for the eyes. Here's the reason in context of activity. Activity purpose. Observe how the pupil changes size in response to light. Pupillary reflex observation. When the torch is on, the pupil constricts, becomes smaller to reduce light entering the eye. When the torch is off, the pupil dilates, becomes larger to allow more light in, helping vision in dim conditions. Safety concern. A laser torch is focused and intense. Likewise, a normal torch. Direct exposure can burn or permanently damage the retina, which is why a normal flashlight is recommended. Summary. Use the regular torch to pupil observation. Never look directly at the laser light. It's harmful. Explain how you can take care of your eyes. 12th question. Taking care of your eyes is very important because they are delicate and essential for vision. Here's a clear and practical guide. 1. Maintain good eye hygiene. Wash your hands before touching your eyes and removing contact lenses. Avoid rubbing your eyes as it can cause infections or damage. 2. Protect your eyes from bright light. Avoid looking directly at sun or bright lights. Use sunglasses that blocks UV rays when outdoors. Never look directly at the laser or the strong torch lights. Third one, follow a healthy diet. Eat foods rich in vitamin A, C, and E, minerals like zinc, found in carrots, spinach, citrus fruits, eggs. Omega-3 fatty acids found in fish and nuts help maintain eye health. Fourth, take care during screen use. Follow 20-20-20 rule. Every 20 minutes, look at something 20 feet away from for 20 seconds. Keep screens at comfortable distance and adjust brightness. Question number 5. Avoid eye strain. Ensure proper lighting when reading or studying. Take breaks from reading or continuous close work. 6. Regular eye checkups. Visit an eye doctor periodically, even if vision seems fine. Early detection can prevent serious eye problems. 7. Protect eyes from injury. Wear protective goggles during sports, lab work, and while using sharp tools. Be careful with chemicals and hot liquids near your eyes. 8. General health habits. Get enough sleep as tired eyes are more prone to strain. Avoid smoking, which can increase the risk of eye diseases like cataracts and macular degeneration. 13. What is the angle of incidence of the ray if the reflected ray is at the angle of 90 to the incident ray? We can use the angle of reflection, which states angle of incidence equal to angle of reflection. Now you said the reflected ray is at 90 degree to the incident ray. That means the angle between incident and reflected ray is 90 degree. Let's denote I is angle of incidence and R is angle of reflection. By the law of reflection, the angle between incident and reflected rays I plus R is equal to I plus I, because angle of incidence is same as the angle of reflection. That's why it is 2I. You are given 90 degree. There is 2I equal to 90 degree. This is given. So I equal to 90 by 2, that is 45. The angle of incidence is 45 degree. Question number 14. How many images of a candle will be formed if it is placed between two parallel plane mirrors separated by 40 cm? Step 1. Formula for images formed between two parallel mirrors. When two parallel plane mirrors face each other, the number of images formed is infinite theoretically. This happens because each mirror reflects the image from the other mirror repeatedly, producing an endless series of images. Step 2. Realistic scenario. In practice, number of visible images depends on the distance between mirrors. Here's 40 cm. How far your eyes can see. Reflection intensity. Images become fainter with each reflection, but theoretically the answer is infinite. Infinite images will be formed. 15th question. Two mirrors meet at the right angle. Like this. This is one mirror. They are meeting at right angle. Ray of light incident one at the angle of 30 degree as shown in the figure. This is the angle of incidence. It is making 30 degree. Draw the reflected ray from the second mirror. This line, how it will reflect the angle of incidence. The ray is falling here and getting reflected at the same angle, that is, this is 30 degree. angle of reflection is also 30 degree. This is 30, this is 30. Okay, and after this, this angle will be, okay, this angle will be 60 degree because these two together makes a 60 degree. That's why this angle of reflection, the light ray of the light reflects at the angle of double that of the angle of incidence, that is 60 degree. Therefore, the answer is 60 degree here. If you draw a dotted line here, this is 30 degree because this is 30 degree. For reflected, the ray reflected from this mirror becomes the incident ray for this mirror. Okay, falls here, angle of incidence at 30 degrees, same again, and it reflects at again 30 degree. Together it forms the angle of reflection, it is 60 degree it is. So, but what happens is these two lines are parallel lines. Let me explain you the notes for this. We have two mirrors meeting at right angles 90 degree. A ray incident on the first mirror at 30 degree with a mirror surface or from normal. We will assume standard convention angle with normal. We need the reflected ray from the second mirror. Step 1, reflection from the first mirror. The law of reflection says angle of incidence is equal to angle of reflection. If the ray hits the mirror at the 30 degree to the normal, it reflects at 30 degree on the other side of the normal. Step 2, path towards the second mirror. Reflection from the first mirror, the ray moves towards the second mirror. Since the mirror meets at 90 degree, the second mirror is perpendicular to the first mirror. The ray now hits the second mirror at 90 degree, that is minus 30, like this also you can calculate, that is 60 degree to the normal of the second mirror. Third step is reflection from the second mirror. By the law of reflection, again angle of reflection is equal to angle of incidence is equal to 60 degree. So the ray bounces off the second mirror at 60 degree from its normal. Overall direction, the neat property of the two mirrors at right angles. Any ray incident on the first mirror emerges along the line parallel to its original direction after two reflections. Okay, first mirror it is falling, and again from there it is getting reflected. Again it is getting reflected from the second mirror. Answer: ray hits first mirror, reflects at 30 degree, it is given to the normal. Ray hits the second mirror, reflects at 60 degree to the normal. Final reflection ray is parallel to the original incident ray. Question number 16. Bujo stands at A on the side of the plane mirror as shown in the figure 13.20. Can he see himself in the mirror? Also, can he see the image of the objects situated at P, Q and R? Okay. Here the Bujo is standing. Can he see his own image? No, he cannot see. It is not Bujo, it is Bujo. Bujo. Bhujo, name. Change the name to Bhujo. Bhujo see himself in the mirror? No, Bhujo cannot see himself in the mirror if he is standing exactly at the point A, because by the side he is standing. If he is standing, the image will form, but he cannot see because the reflected ray, his the ray reflected, the ray fall on his body. That ray falling, light falling on his body, get reflected and falls like this. Yeah, and after hitting the mirror, it reflects in this direction. If somebody is standing here, he can see his image, not himself, because that image is not falling on his retina. Standing exactly at point A, which is just beside the mirror and not in front of it. For a person to see their own reflections, light rays from their body must reach the mirror and reflect back into their eyes. Since Buju is standing at the edge, yes, you modify the name, edge, his eyes are not facing the reflective surface directly. So his own image won't be possible unless visible, unless he moves slightly in front of the mirror. Here he is standing, little bit here he should move. Then he can see his image. Then if he stands at the point P, he can see his image. Directly falls on his retina, he can see his image. If he stands Q at the Q, no, he cannot see his image. At or also he cannot see. Seventeenth A. Find out the position of the image of object situated at A in the plane mirror. Find out the position of the image of an object situated in the plane mirror. Image will be formed here behind the mirror. You can see if you're standing here. B can Paheli at B can see this image. She is standing here. Probably, depending on the position, she may see the image. Can Bujo at the C can see this image? Maybe not, probably not. Reflected light will fall on B, not on C, I think so. When Paheli moves from B to C, where does the image of A move? No, it will not move. Image will not move because it is A's image. A is standing still. That's why image is also not moving. A position of the image of an object A in the plane mirror, the image of the object appears directly opposite to the object at the same distance behind the mirror as the object is in the front. So if object A is in the front of the mirror, its image will be located behind the mirror at the same distance and along the line perpendicular to the mirror surface. The image will be virtual, erect, and laterally inverted. B. Can Bahili at B see the image of A? To see the image, light rays from A must reflect off the mirror and reach Bahili's eye. If Bahili is within the reflected ray path, then yes, she can see the image. Based on the diagram, Bahili is positioned above and slightly to the side, so she likely can see the image of A, assuming the mirror is large enough and not blocked. C. Can Bujo at C see the image of A? Bhujo is directly below Pahili and also facing the mirror. If mirror is tall enough and Bhujo's line of sight intersects the reflected rays from A, then S, he can also see the image. But if the mirror is short or A is too far to the side, he may not be able to see. D. When Pahili moves from B to C, where does the image of A move? It will not move. The image A does not move because the object A is stationary and the mirror is fixed. What changes in Paheli's position? So her angle of view changes. She may see the image from different angles, but the image itself remains in the same position behind the mirror. Please like, share, subscribe, comment, and save the playlist. Thank you very much. Bye bye.